Welcome to JD's Prep. In this problem, we're told that Paul plans to have a rectangular garden adjacent to his garage. He will use 36 feet of fence to enclose 3 sides of the garden. The area of the garden in square feet can be modeled by the function f of w equals w times 36 minus 2w, where w is the width of the garden in feet. The first thing we want to do is graph that function f of w on the set of axes below. Now, one way you could approach this is just to plug the function into the calculator and see what the shape is going to look like. But that's not going to give you necessarily all the information that you need in order to make your graph accurate. So what we can do is we can look at the type of function that we have and see what we know about the graph and some points on the graph to make the graph a little more accurate. The first thing to point out is that for this function, if I distribute the w, I'm going to get the function f of w equals negative 2w squared plus 36w. The squared there tells us that this is a quadratic function, and the graph of a quadratic function is a parabola. With parabolas, if we have 2 points that have the same y value, then the vertex is going to be halfway in between those 2 points. So if I can find 2 points on the graph that have the same y value, I can just go halfway between them in order to find the vertex. Since the function is already factored for us, that becomes a little bit easier by looking for the x-intercepts. I'm going to find the x-intercepts by saying that w times 36 minus 2w is equal to 0, which, using the zero product property, I can find that either w is equal to 0 or 36 minus 2w equals 0, which means w would be 18. So I have one x-intercept down here at the origin, and I have one x-intercept over here at 18. Those are 2 points on the graph. Halfway in between those 2 points, in other words, 0 plus 18 over 2, which is 9, 9 is where the vertex is going to be. And so, coming over here to the 9, if I plug in 9 to the function, the y value that I get back, the f of 9 that I get by plugging in, that's going to give me the y coordinate for the vertex. If I do plug that in, f of 9, I have 9 times 36 minus 2 times 9, which is 9 times 36 minus 18, which is 9 times 18, which is 162. Plotting that on the graph, we can come to x equals 9, and then go up to just a little bit above 160, and we get our y value there. So our graph is going to be a parabola that starts down at the origin, goes up to the vertex at 9, 162, and then comes back down to the other x-intercept at 18. So this is what our graph is roughly going to look like. The other thing we want to do is explain the meaning of the vertex in the context of the problem. And in order to do this, it's important to remember what the function is modeling. And the function is modeling the area of the garden in square feet, with the variable w being the width in feet. So since our vertex is the point 9, 162, and for this parabola, the vertex is the highest point on the graph, that means that the area f of w, right, the area is largest when the width of the garden is 9 feet. The y-coordinate of that vertex, the 162, means that the largest possible area for the garden is 162 square feet. So the largest possible area for the garden is 162 square feet. Anytime you have a quantity that is being measured or modeled by a quadratic function, the vertex of the parabola, whether it's the highest point on the graph or the lowest point on the graph, is giving you either the maximum or minimum value of whatever quantity it is that you're measuring. In this case, we were measuring the area and the vertex was the highest point, so the maximum possible area was 162 square feet, which occurs when the width of the garden is 9 feet.